A smooth sphere of mass 3 kilograms collides directly with a smooth sphere of 5 kilograms. Their velocities before impact were 10I and I respectively. If the lesser mass is brought to rest by the impact, find the coefficient of restitution between the two spheres, right? So what happens here is, I always tend to draw diagrams, okay? So, here you go. Now, they're both going in this direction. One of them's going at speed 10, the other one's going at speed 1. It's not going towards it. How do I know it's not going towards it? 1I. Okay? So what question is this? 3, isn't it? Yeah. Okay, now, mass is, the smaller one has a mass of 3 kilograms, the larger one has a mass of 5 kilograms. After the collision has taken place, what we're left with is the before and after scenario, right? So this is the after scenario. The after scenario would be basically that the first ball has come to rest, so its velocity is now 0, and the second ball does it give us the speed of the second ball after the collision? Doesn't. Okay, so let's just call it V. Now, there's always two equations that you have to do. One of them is called PCM, it's known as the principle of conservation of momentum. Anybody know it? Okay. Principle of conservation of momentum means your momentum before collision equals your momentum after collision. So mass 1 times its velocity before collision plus mass 2 plus its velocity before collision must equal mass 1 multiplied by its velocity after the collision plus mass 2 multiplied by its velocity after the collision. That makes sense? Okay. Now, the second thing is called NEL, Newton's experimental law. Now, let me see if I can remember this. Yeah. Minus V2 or V2 minus V1. Okay. Minus E equals V1 minus V2 over U1 minus U2. Let me explain what this means, okay? I'm going to do a simplified version of the question to explain what Newton's experimental law means, okay? If I had a collision, and the collision is that the first one's going in at let's say 20, let's go 26. This one here is coming in at 6. What's their velocity relative to each other?
20.
Their velocity relative to each other is 20. Okay? After they collide, their velocity relative to each other becomes like this. This one hasn't quite stopped. Let's say he's going 5, and this one here is going let's call it 15. Okay, so is that possible? Actually, just for a second, 5 and 15. Yeah, should be okay. Now, what happens is you have U1 is the velocity of particle 1 before collision. V1 is the velocity of it after the collision. U2 is the velocity of the particle 2 before collision, and V2 is the velocity of particle 2 after the collision. Okay? So when we do U1 minus U2, it's going to be 26 minus 6. When we do V1 minus V2, it's going to be 5 minus 15. This results in being minus 10 over 20, which is minus a half. Minus a half equals minus the E value. The E value for that collision was a half. Does that make sense? E value was a half. Okay? I'm going to do a second collision for you now. Here's the second collision. Second collision, we've had cases where they're both going in the same direction. In this case, they're not both going in the same direction. This time around, this one is going towards it at 5. or towards it at 4, let's say, okay? After the collision takes place, what happens next is this one is going forward at 10, while this one here will be going backwards at 2. Yeah.
Do you have the keys for the TG?
Just give me a second. So lads, what we have here this time around is, okay, you looking guys? Shh. This is before, the top picture is before the collision, the bottom picture is after the collision. So what we have is two particles going to bump into each other, okay? So what happens here is that you can see that Newton's experimental law, it's completely, the masses are completely irrelevant. It's all relating to the speeds, okay? So it doesn't matter if one of them's 10 kilograms, the other one's 20 kilograms. It only relates to the speeds because there's no m's in this formula, okay? So using this one here, what we're going to say is that U1 and that's U2. What's U1 minus U2 this time? It's going to be 26 minus 4. U1 minus U2 is the relative velocity they're coming at each other. They're coming at each other with a speed of 30 when combined. So that's why it's going to be 30 on the bottom. And what's it going to be on top? It's going to be phi1 minus phi2, which is going to be minus 4. And the E value for this collision will be minus 2, as will be 2 over 15. Okay, that's how this formula works. Okay, so back to the question at hand. Eventually. Okay. And there we go. Okay. Back to the question at hand, okay? Find the coefficient of restitution between the spheres. That's what we have to do. Okay, so first thing we're going to do is we're going to make a formula. Okay, so we're going to start off with, let's start off with Newton's experimental one. Okay, so we're going to have for Newton's experimental law is we're going to have 10 times, that's going to be U1, V1, U2, V2. Okay, now, what we're going to have here guys, 0 minus phi. Does everybody see where I got 0 minus phi from? Just label them before and after collision. U1 minus U2, 10 minus 1. Your formula for E is minus phi over 9, or E equals phi over 9. Now we'll have to use the principle of conservation of momentum to find out what exactly is V. So M1, what's the mass of the first one? It's going to be 3 times 10 plus mass 2, which is going to be 5 times 1 equals M1 times phi1, which is going to be 0, and then finally 5 times V. 30 plus 5, 35 equals 5V. Phi therefore equals 7. The answer for the coefficient of restitution therefore is 7 over 9. So the answer to that one is 7 over 9. Velocity of the greater mass after the collision, 7. The impulse imparted to each of the spheres. How do we do impulse again, guys? Anybody remember impulse? Huh? Equals momentum before minus momentum, oh sorry, mv minus mu, momentum after minus momentum before. Now, you can take either particle you want. You can take the 5 kilogram particle or the 3 kilogram particle. You should get the same answer both times. Okay, we'll wrap this up in a second, okay? So, let's start off with the 3 kilogram particle. After the collision, it is 3 multiplied by 1. 3 kilograms moving 1. Before the collision, 3 kilograms moving 10. The answer to this is 29 kilograms meters per second. Okay? What happens if we took the second particle instead? Okay, what was its what did we say phi was again? V was 7. Okay, so just add more. Okay guys, sorry guys. Phi was actually 0 because it actually wasn't moving at all after the collision. So this actually makes the whole thing 30. Okay, and finally the impulse for the second one, the 5 kilogram particle was moving 1 to the right before the collision took place. After the collision took place, it was moving 7 to the right, and this once again gives you 30 kilograms per meters per second. If after impact the greater mass moves another 2 meters, find its deceleration. That's just a UVAST question, lads. UVAST would be UVAST. S equals 2 meters. We want to find its deceleration. Its velocity is 0. Its U value is 7. We want to find A. So phi squared equals U squared plus 2AS. 0 equals 49 plus 4S. 4S equals 49 minus 49 because it's a deceleration. S equals minus 12.25. Oh, sorry, A equals minus 12.25 ms to the minus 2.